I'm Dr. Mamta Bhusry from Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. This is my third lecture on concurrency control in database management systems. As already mentioned, the recommended books for concurrency control are Database Concepts by Korth and Fundamentals of Database Systems by Nawathe. I have already covered with you locking techniques, that is two-phase locking protocol and multiple granularity protocol, and the timestamp based techniques, under which we have done the timestamp ordering technique, and now we will take up the validation based protocol followed by the multi-version techniques. The validation based protocol, also called the optimistic concurrency control technique. In the concurrency control techniques that we have already studied, that is the log based technique and the timestamp ordering technique, there is a certain degree of checking required before the database operation can be executed. This checking includes that a check is performed to see whether the data item is already locked or not in the locking protocol, and in the timestamp ordering protocol, the transaction timestamp is checked against the read and the write timestamp of the data item that is being accessed. Such checking represents overhead during the transaction execution with the effect of slowing down the transaction, and hence these techniques are called the pessimistic techniques. The validation or the certification techniques, they are referred to as the optimistic techniques because there is no checking required while the transaction is executing. Updates are made by the transaction and are not applied directly to the database items unless the transaction reaches its end and commits. During the transaction execution, all the updates are applied only to the local copies of the database items that are kept for the transactions. At the end of the transaction, a validation phase is applied that checks whether any of the updates may be violating the serializability. If the serializability is not violated, then the transaction is committed and the database is updated from the local copies. Otherwise, the transaction is rolled back and is restarted later. In the optimistic or the validation technique, each transaction is made up of three phases: a read phase, a validation phase, and a write phase. The read phase starts with the activation of the transaction. During the read phase, all the data items are read into the local variables of the transaction, and any modification to the data item is made in these local copies. In the validation phase, the database management system checks that the modification made to the data items will not cause any inconsistencies to the database. Any possibility of the inconsistency due to modification will cause the transaction to roll back. If the transaction passes the validation phase, then the modifications made by the transactions, they are written to the database and the transaction is committed. These three phases of the concurrently executing transactions can be interleaved, but for each transaction, all the three phases must be executed in the order of read, validate, and write. Also, each transaction Ti has three timestamps associated with it: a start timestamp, a validation timestamp, and a finish timestamp. The start timestamp is when the transaction has just started or when it has started its read phase. The validation timestamp is the time when the transaction finishes the read phase and enters its validation phase. This occurs when the transaction has completed the changes in the local copies of the variables and the modified items are held there. The local copies are not accessible to the other transactions that are occurring in concurrency. The finish timestamp is the timestamp when Ti finishes its write phase. The write phase will start only if the transaction completes the validation phase successfully. After the write phase, all the modifications are reflected in the database. The optimistic scheduling technique works as follows. Any transaction Tj can complete its validation phase successfully if for all transactions of the type Ti with Ts of Ti less than Ts of Tj. That means all the transactions of the type Ti which are older than the transaction Tj, one of the following conditions holds true. First condition, the finish of Ti is less than start of Tj, that is the transaction Ti has completed all its phases before the transaction Tj starts. The second condition, finish of Ti is less than validation timestamp of Tj, that is the write of Ti does not overlap with the read of Tj or Tj reads after Ti has finished writing. This ensures that the younger transaction writes are not overwritten by the writes of the older transaction. The third condition is that validation of Ti is less than the validation of Tj, that is Ti completes its read before Tj completes its read phase, so that the older transaction cannot influence the read or the write of the younger transaction. These three conditions, they are checked one by one, that is the first condition is checked for each transaction Ti which is older than Tj. Then if this condition is false, then the second condition is checked, and only if the second condition is false, then the third condition is checked. If any of the three condition holds true, then there is no interference and Tj is validated successfully. But if none of the three condition holds, then the validation of Tj fails and it is aborted and restarted later. Next, we will take up the multi-version schemes. The concurrency controls schemes done till now, that is the locking and the timestamp ordering, they ensure serializability either by delaying an operation as in the case of locking or aborting a transaction as in the case of timestamp ordering. These difficulties can however be avoided if older copies of each data item they are kept in the system. This is achieved through the multi-version concurrency control schemes. Multi-version schemes preserve the older copies of the data item when the data is updated. When a transaction requires to access a data item, then an appropriate version of the data item is chosen to maintain the serializability of the schedule. When the transaction updates the data item, then it writes a new version and the old version is retained in the system. We will study two multi-version schemes. First is the multi-version scheme based on timestamp ordering, and the second is the multi-version two-phase locking scheme with timestamp ordering. First, let us take up the multi-version technique based on timestamp. Here several versions of the data item, say x1, x2, x3 and so on, they are maintained in the system. Each version of the data item will consist of the content value of the data item, the read timestamp of the data item, which is the largest of all the timestamps of transactions that have successfully read the version of xi, and the write timestamp is the timestamp of the transaction that wrote the value of the version xi. Now, the multi-version timestamp ordering scheme operates as follows. Say a transaction Ti issues a read x or a write x, and xk is the version of x whose write timestamp is the largest timestamp less than or equal to ts timestamp of ti. Then if ti has issued a read x, then the value returned is the content of the version x, that is the latest version that is existing. If ti issues a write x, then if the timestamp of ti is less than the read timestamp of the version, that is ti is an older timestamp as compared to that is ti is an older transaction as compared to the transaction that last read the value of the version xk, then the transaction ti is rolled back. If ts of ti is equal to the write timestamp of xk, then the system overwrites the value of the content and the timestamps are set as write timestamp of xk is equal to read timestamp of xk is equal to timestamp of the transaction ti. If the transaction ti has timestamp greater than the read timestamp of the version x, then a new version is written, let us say xk plus 1, and the read and the write timestamps of the new version, they are set to ts of ti. If ts of ti is greater than write timestamp of xk, then ti writes a new version, again let us say xk plus 1, and the read and the write timestamps of xk plus 1, they are set to the timestamp of the transaction ti. The next scheme that we will take up is the multi-version two-phase locking with timestamp ordering. This scheme clearly differentiates between read-only transactions and update transactions. Read-only transactions are those which are only for reading the value of the data, whereas the update transactions are those which can read the data as well as update the data. Update transactions in this case perform the rigorous two-phase locking, that is they hold all the locks, that is shared and exclusive locks, unless the transaction commits, and the transactions are serialized according to their commit order. In this case, each version of the data item has a single timestamp which is generated by the logical counter and is not a clock based timestamp. The multi-version timestamp ordering protocol is followed for performing the reads, that is the reads they are done in a manner as the multi-version timestamp ordering protocol which we have just done. Thus, when any read only transaction ti issues a read x, then the value of x returned is the content or the version whose timestamp is the largest timestamp less than or equal to ts of ti. An update transaction can read as well as write to the data item. When an update transaction reads the data item x, it gets a shared lock on the data item and reads the latest version of the data item. When the update transaction wants to write to the value of x, then it acquires an exclusive lock on the data item and then creates a new version of the data item. The write or the update is performed on the new version. The timestamp of the new version is initially set to infinity, which is a value greater than any other possible timestamp. When the new version has been updated, the commit process is carried out as follows. The transaction ti sets the timestamp of the version it has created to 1 more than the value of the counter, and the counter is incremented by 1. The read-only transactions that start after ti increments the counter will see the value updated by ti, whereas that start before ti updates the counter will see the value of x before the update by ti. In either case, the read-only transaction will never have to wait for the locks. The multi-version two-phase locking protocol ensures deadlock-free schedules, and it also ensured cascadeless schedules as there is no rolling back of the transactions. Thank you.